In this video, we will see few more problems in moments as a continuation of the last one. We recollect that moment is nothing but expected value of a random variable raised to the power of r, an integral power when it is a raw moment, and that the deviation is going to be taken about the origin. And when it is going to be central moment, you have the expected value of x minus mu. The deviation is taken about the mean, and then you again raise it to the power r. So this is going to be called as your central moment. Okay, so now we will have the first problem, which says if f of x is a continuous random variable with probability density function f of x is equal to 2x for 0 less than x less than 1 and is going to be 0 elsewhere, then find the first three moments. So when it is generally referred as moments, by default we refer to the raw moments. Raw moments mean expected value of x to the power of r. So what are going to be the first three raw moments? It is going to be mu1 prime, mu2 prime and mu3 prime, which is given by expected value of x to the power of 1. The next one is expected value of x to the power of 2, and the third one is expected value of x to the power of 3. Now we have been given with a continuous random variable. It lies between the range 0 to 1, taking all the values in between it. So when it is going to be a continuous random variable, the expected value is given by integral. If it is x here, then x into f of x dx. So what will be e of x square? It is integral. What is over the random variable? X square into f of x dx. And when it is e of x cube, the value is going to be x cube into f of x dx. So now substituting for f of x from the given problem, so this becomes x into 2x dx between the limit 0 to 1. So we have it to be 2x square on integration dx between 0 to 1 gives you 2 into x square gives you x cube by 3 between the limit 0 to 1. So when we apply the limit, you have it to be equal to 2 divided by 3. Now let us move on to the second order moment, which is given by integral x square into f of x. F of x is 2x dx between the limits 0 to 1. So it is totally 2x to the power of 3 on integration between 0 to 1 dx. So it is 2 into x power 3 on integration is x power 4 by 4 between the limits 0 to 1. Now this can be cancelled off over here 2 times. So the total value now becomes equal to 1 divided by 2. So how about your third order moment? It is x cube into f of x. F of x is replaced as 2x dx. So this varies between 0 to 1. So you will have 2x to the power of 4 on integration between 0 to 1 dx. So this gives you 2x power 4 on integration is x power 5 by 5 between the limits 0 to 1. So the final answer will be 2 by 5. So hence we have estimated the first three moments for the function f of x is equal to 2x for 0 less than x less than 1. Now next let us move on to a second problem where we have that the first three moments about the origin, are given as 5, 26 and 78. We have been asked to show that the first three moments about the value x equal to 3 are 2, 5 and minus 48. Okay, so we have been given the first three moments about origin. So what we know is we have been given e of x to be equal to 5, e of x square to be equal to 26, and e of x cube to be equal to 78. We have been asked to find the first three moments about the value x equal to 3, that is mu expected value of x minus 3 power 1, the first moment about 3. Next we want e of x minus 3 power 2, the second moment about the point 3. The third one will be e of x minus 3 the whole to the power of 3. So now expanding this to the power 1, we have this as e of x minus e of 3. So e of x is nothing but 5 minus what we know about e of 3. E of 3 constant is a constant. So 5 minus 3 we get it to be equal to 2, and hence we are right with the answer. Now moving to the second part, e of x minus 3 the whole square. So we have it as a minus b the whole square. So this gives us e of x square plus 9 minus 3 2s are 6x. Evaluating it for individual of the term, we have e of x square plus e of 9 minus e of 6x. Now we know e of x square, which has been given as 26. E of 9 is a constant, so that makes it as 9, minus e of 6x is e of ax, so a the constant comes outside, so 6 the constant comes outside, so you just have this as 6 times e of x. So what is our e of x given as 5, so this becomes 6 times of 5, so it is 26 plus 9 minus 6 5s are 30, so that makes it as 5 totally. Now moving on to the last one, we have a minus b the whole cube. So expand it using a minus b the whole cube formula, e of x cube minus 3a square b plus 3ab square minus b cube. So this makes it as, split it separately, e of x cube minus 3 3s are 9, 9 times e of x square, 3 square is 9, 9 3s are 27, so plus 27 times e of x, and this is going to be a constant, and expected value of a constant is constant, so you have 3 cube, 3 into 3 9, 9 3s are 27 to come outside. Now you e of x cube can be substituted as 78, e of x square can be substituted as 26, and e of x can be substituted for 5. So next step, we have this to be equal to, so this is going to be 78, and this is going to be minus 9 times of, this is going to be substituted as 26, and e of x will be substituted for 5, and minus 7, so this makes it as minus 48. Yes, we are done with the third part too. So when we have been given about any point, we can just take the expansion for the power and then substitute the given values of it, and this will evaluate the moment about any particular point.